Lately, we hear a lot about ocean warming, and so here we are, right at NASA's site, checking it out. And you can see the blue. The blue represents cooler water. Then it goes into kind of pink as it warms, and then sort of orange, and then white where it's the warmest. And I just want to point this out here. This would be the Labrador Current, which probably 100 years ago, there'd be a line. This is the Gulf Current here, which is obviously warmer, but there would have been a line dividing the two that went kind of right through this area here. And everything above this line would not be, it would be blue. And you can see up here at Iceland, we've got a lot of pink running up through here and then over Norway, Finland area. So what's happening? Why is that? I'm going to make a suggestion that you may not have heard of yet. It's this. These are all ships. And just as a little reference here, this is the merchant fleet as of January 2023. And you see we've got 18,353 smaller cargo ships. And we've got all these bulk cargo ships, crude oil tankers, chemical tankers, container ships, passenger ships, and liquefied natural gas tankers. So we got a lot of ships out there. This adds up to more than 60,000 here. And there they are. And as you can see, I mean, we were talking about why is it pink up here now. Look at all the ships around Iceland. Look at all the ships running up the coast of Norway here. I mean, there's just so much ship traffic that wasn't here 100 years ago. And something you may not know about ships, they don't have radiators to cool their engines, and they've got some huge engines. Now, what they do have is something called a heat exchanger, and this is just a diagram of one. And what happens is they take the engine oil and other cooling fluids from the engine, and they run them in, and they go through all these tubes, and then they come out. When they go in, the oil may be 120 or, it's hot. You don't want to put your hand in the oil going in. And really, you don't want to put your hand in the oil coming out, but it's much cooler. But what happens is this is seawater directly from the ocean surface coming in and then going around these baffles so that the tubes get kind of a equal distribution or a better distribution of the coolant around these tubes full of oil. And then it goes back out right into the ocean. Now, it hasn't come in contact with the oil unless there's a mechanical issue on the ship, but it comes back out 4 degrees Celsius warmer, which is more than 20 degrees warmer. Now, imagine 60,000 ships doing that. Every one of them, as they cross the ocean here, every one of them is laying down a stream of water in the surface water that's 20 degrees Fahrenheit, 6 degrees Celsius warmer. Now, obviously, that's going to add up, and these pictures are pretty much a clear indication that that is happening. Oddly enough, I mean, there are places here, look, this hasn't warmed up. It's not a heavily trafficked area for shipping at this point in time. So I'm convinced. Well, here's it. That current I was talking about comes up in here, goes up into Baffin Bay, gets cooled a little bit more, and then comes down, and then goes and heads toward New York, and then it catches a North Atlantic current and heads towards England. And for hundreds of years, sailing vessels with sails rather than motors used to ride that current. Is this a big part of the global warming issue? I think it is, and I also think there's something to do about it. And I'll put some of those links in the description below to some other videos explaining how the processes would work. But one is aeration, where you take this very cold air up here and you blow it through diffusers under the ocean or under the ocean surface, where the bubbles will rise up. And up in here, you could actually probably create ice. You get up here further north by just blowing bubbles through the water. And one of the links that I'll provide shows actually blowing bubbles on a very small scale through the water and shows the temperature changing. Another way to do it is, you've probably seen firefighting ships where they blow these plumes of water that are they're huge, and if you blow them out over the water up here, you'd be sucking up water from the surface, which is well above freezing, obviously, and before it hit the water again up in these areas, a large percentage of it could actually be close to freezing temperature. So these are two things that we need to consider requiring on these ships to offset the heat that they're creating. And if we did that on every ship up through from here north, we'd probably see a lot of expansion of the ice on the polar cap, and the same down here toward Antarctica. So this is something we need to really put into the equation. Stop thinking that we're going to drop the amount of emissions in time to stop. I mean, we've already lost hundreds of people to these monster storms, and if this temperature doesn't start to drop, those monster storms are probably going to increase in intensity and in numbers. So go to the press, go to your representatives, and go to your neighbors. Tell them about this video. Let's get something going before we lose too much more friends, family, businesses, infrastructure. We're losing too much, and I'm convinced a large part of it is because we're just letting these ships go around sucking in the ocean water and pushing it back out a lot warmer. And we need to stop this. Well, we can't stop it, but we can make some amends to it. Actually add some cool to take away from the heat that's being added. So thanks for watching.